Welcome back. It's a continuation video for the transfer function of a DC servo motor. So I'm quickly recapping the things like it has a few forgot or something. So I'm just recapping the equations. So if you see, this is the equation for that is the equation related to the voltage with respect to current and back EMF. And here these are related to the mechanical equations. So see the mechanical equation and electromechanical equation. In the last video, we discussed it up to till this slide. Okay, so now we are going to discuss about the next thing. So that is whatever this models are there, that we need to transfer into the Laplace domain equation. So regarding that one, Laplace domain, so we are having taking Laplace domains, the electrical equation separately and the mechanical equation separately. Then only we can understand, because if we completely merge up means, then automatically sometimes it may connect or it may not connect. So that's why we are regarding that considerations we made a little bit of separation. So that one. So if you see here, so as per that one itself, VA of T, initially we wrote resistance, inductance, and the here KB I took that normally to get the understanding of all the K terms. They are very less terminologies will be there, very less in component wise. So that's why we took it as a that it is a normally a EB component, that means back EMF component. And the mechanical, this already you know KT into K of T, that means torque, and the what is the inertia with respect to that one, and the flux with respect to that one. So this is how the same thing it is happening. Now what we need to do is we need to transfer the whatever derive the transfer function. We are going to derive the transfer function. So regarding that one, for the from the first mechanical equation, whatever the R of a K of T is there in the left hand side, that means LHS side, that K of T will be transferred to that one. K will be transferred to right hand side. So then what will happen? It will be coming into the denominator. So then I of S current equation will be equals to the J into S square plus B into S into theta of S by K underscore theta will be there. So when we are substituting this I of S in a equation of theta S by VA of S, then what will happen is we will get a equation, final transfer function will be related to this one. So it is a complete final transfer equation, because I'm not taking a step-by-step equations for with respect to the I of S after after substituting in the equation what will happen. Then after that, what how it is solving, how it is next step, what it is solving, like that. I'm just making it a complete one equation, which is the final equation. This is the final transfer function. If you see the final transfer function, it is an, as I already said, the transfer function is related to the both the voltage, input voltage, right, and also the motor angular position. So that's this is how the final equation will come. Okay, so that final equation, so motor angular position and also voltage which is feeding to that one. So K of T and the inductance. And also here if you see in each and every terminology we are having two terminals, two terms are there. One is about one is about electrical quantity, another one is a mechanical quantity. So inductance is torque, inertias, resistances, each and everything which is having a both mixed of the terminologies with respect to electromechanical. So that's how why we need to mix the both equations. So that's why we said before itself mixing the two equations. Okay, now if you see the exactly the thing, so S cube is there, right? S cube means it is a third order function. Okay, where whatever the domain degree of the S is there, that is calling as the order of the system. So that's why this is the third order system describing the position control. But for the third order system, so what exactly we need to do is we need to reduce the transfer function. So regard to reduce the transfer function, what we are considering is we neglecting the inductance, because the inductance whatever it armature inductance whatever will be there, it will be having a very less component will be there. So regarding that thing, we neglecting that one for a simplification purpose. Then automatically what will happen is the order of the system will be reduced to the second order. When the second order system is there, you can easily find out, or we can easily derive the whatever the denominator separations will be there, equations, relations, it's easily can able to analyze. This is how we can able to design, or we can able to reduce the transfer function. If you are not using a S domain or the Laplace transform, the equation may get very huge or may get less also. But standardly, when you are using a transfer function, sorry, Laplace domain means automatically your function, how much big it will be comes to the very less. So we can make this assumptions each and everything. Okay, now you will see the real world applications, where exactly this real world applications of the servo motor is happening. Okay, so as we discussed in the first slide, this model will helps the designing in the position of the controllers of the CNC machines. Okay, CNC machines will be there, and also robotics in many parts like the head, arms, each and everything we can do. Then antenna position system. If you see the antenna position, it may goes to the slightly less, slightly bending, slightly to moving on top of, according to the where the signals are coming. So that can be done through only this type of motors. You can able to do that one. And the medical devices, I will show you one image to you to understand how exactly the medical devices is happening. So if you see this image, so this is can be completely operating by a machine, which can be done through this whatever this under this thing is the mechanism is there. This mechanism is completely related to the servo motor itself. Okay, so not only the in the electrical, not only in the normal electronics, so it is also using in the medical part also. Okay, medical application. So this is how the DC servo motor is using in real world applications. Thank you.